Okay, welcome back. Here we are for the second uh, Blackboard video on ellipse numericals. I'm calling it Ellipse Numericals 2, and basically I'm going to be working on two numeric examples similar in ways, well, one of them is anyway, to the problem set take home on ellipses. Okay, these are called type 2 ellipses because they are higher than they are wide. And when you have that kind of situation, this is your basic pattern. The A goes with the vertical axis because the vertices are going to be located vertically. Okay? Notice with the other type, with the type 1, you have the A squared here. So the standard form depends on which type of ellipse you're dealing with. So that's something you have to be a little careful about. All right, now the idea is, how do you tell? Well, it's actually pretty easy. This is the information given. We have vertices at 3, -4, okay? And we have another vertex at 3, 2, and we have one focus at 3 comma -1 minus radical 5. Okay, so the idea is from plotting these points, I can tell that the vertices here and here are denoting an ellipse which is of type 2. So that's how I know. Basically, just take the information you have, you plot points, you look at it. Okay, so that's the idea. So let's get a couple of pieces of information from vertex 1 to vertex 2. Well, let me write this down here. Vertex 1 is 3 comma -4, and vertex 2 is 3 comma 2. Now that distance is 2a. So therefore, if you have a difference of 6, then we know immediately a equals 3. Okay, so a equals 3. And what we'd like to do is we'd like to get B and C. Well, let's take a look. Well, first we need the center. So let's get the center, and the center is going to be the midpoint of V1, V2. So the midpoint, you can just count boxes. It's going to be 3 comma something. So it looks like if you add 2 and -4, you get -2. Half of that's -1. So it looks like 3, -1 is going to be the center. Okay, so the center is 3, -1, and therefore this is your H, and this is your K. So we now know it's X minus 3 quantity squared, Y minus a -1, Y plus 1 quantity squared. Okay, and if A is a 3, then A squared is a 9. So far we've gotten a lot of information, and what we're missing now is the B. So let's try and go ahead and get the B. Now, we know A is 3, okay? And if this is the center, then this length here represents C. Okay, so as you can see, a little joke, as you can see, looking at the coordinates of the focus, okay, the 3's are the same. So what we're looking at is the difference between the y values. And I both start with a -1. We're counting down radical 5. So C is therefore a radical 5. So what we're going to do is we're going to go from the center and count up and down radical 5. Now, radical 5, you should know 2.236. You're doing the calculus, it's about 2.2. So if you work at the center, and you go up about 2.2 units, you'll get the other focus. And it's easy to get the coordinates of that, right? I'm just counting 1, 2, and a little bit more, right? So the other focus would be, well, height of -1 plus radical 5. So it's going to be 3 comma -1 plus radical 5. And that would be the other focus. So if this one was focus 1, this would be the coordinates of focus 2. And don't forget, what we sometimes do is we sometimes write the foci like this, -1 plus or minus radical 5. So these would be the foci then. Okay, so we were given one, we can get the other. Well, again, you've got A and C, so you can get B, and that's going to help us fill in this. And that will give us the rest of what we're looking for. Okay, so let's go on with that. And in an ellipse, you're supposed to know A is the greatest value, right? So therefore, A squared equals B squared plus C squared. A squared is 9, C squared is 5, so B squared is 4, and B equals 2. So that's our other important value. And therefore, B squared, and B is 2, B squared is a 4. So this gives us our standard form version. Okay? And now the next thing that we need to do, well, let's see if they ask us about the axes. All right, so the major axis has length 2a, and since we know a is 3, that has a length of 6. And the minor axis has a length of 2b, so that's going to be the width, right? So b is a 2, 2b is a 4, so that's another thing that might be asked. And if they asked us what are the coordinates of the endpoints of the minor axis, well, that's kind of easy, right? You just go ahead here. It's got the same heights. It's got a height of -1. So you have you going over 2 units in this direction. So that would be 5 comma -1. So that would be, and then from the center, this is the center, right? You're going 2 units over in this direction. So that would take us just counting to 1, -1, and that would be the other vertex, in case you're asked, of the minor axis. Okay, so let's see, what else do we know? Lattice rectum. Okay, so lattice rectum is 2b squared over a. Let's plug the numbers in. So b is a 2, so b squared is a 4. 2, so 2 times 4 is 8. A is a 3, so that's 2 2/3 is the length of the lattice rectum. Okay, so that would be, let me get another color here to make it stand out a little bit better. Length of the lattice rectum is 2 2/3, so you go through the, focus, you're going 2 2/3 this way, so that means about 1 1/3. Trying to do as best I can. So that would be, so these are the endpoints of your lattice rectum, 1 1/3 here, 1 1/3 here for 2 2/3. Do the same thing here. Okay? And what that's going to do is when we go to make our sketch, which is pretty close to almost now, that's going to help us decide how, plump, I guess that's a word, how plump this is. Okay, so here we go. Not that good. This is the hardest part, really. Okay, and that's not it. And in case you're asked for the eccentricity, which I neglected to do on the last one, I forgot. It's easy. It's C over A. So C is radical 5, and A is a 3. All right, so if you put this in your calculator, this is 2.236 divided by 3, so it's about 0.7 and change. And we're supposed to know that for an ellipse, the eccentricity is between 0 and 1. Okay, so I'm going to pause that here. And what I'm going to do is I'm going to clean off the board, and then we're going to come back in the same video after the pause, and I'm going to do a second type of numerical. Okay, so hold on, please. Okay, we're back, This isn't focusing. I don't know what happened. Yeah, there we go. Okay. All right, we're back. So in this case, we're writing the ellipse as some form of a quadratic here. And let's see, let me check, make sure I wrote it right. 9x squared minus 54x plus 4y squared plus 32y plus 109 equals 0. And at this point in time, we do not know what kind of a curve this is going to be. Well, I guess we do a little bit. We can guess. First of all, again, since we have an x squared and a y squared, we know it can't be a parabola because a parabola has only one of the variables squared. Since the numbers in front are not the same, it can't be a circle. So we've got something squished, and basically you can think of an ellipse as a circle which has been squished. Okay. Okay, so what we're going to do is the technique is completing the square. So I hope this thing gets into focus better. Okay, I guess I shouldn't be in the picture then. All right, so what we're going to do is I'm going to try and look at my x terms, immediately factor out the 9. Okay, with the y terms, immediately I'm going to factor out the 4. And I'm going to move over the 109. Okay, and then the idea is I complete the square. Half of this is 3, 3 squared is 9. So realize, of course, 9 times 9, I'm really adding an 81 onto the left side, so I add it onto the right side. Half of this is 4, 4 squared is 16, 4 times 16 is 64. So I'm really adding a 64 onto the left side. So when I combine this, okay, I get, okay, when I add this up, I get 145 positive minus 109, so that comes out to 36. So this is a cooked problem. The numbers specifically work out nicely. And we're supposed to know that in standard form, you want to have a 1 here. So that means divide everything by 36. This will become a 1. Here I'll get a 9 on the denominator. Here I'll get a 4. So I get x minus 3 squared over 4 plus y plus 4 squared over 9 equals 1. Okay, so this would be our standard form equation, and you can tell it's an ellipse. And since the 9 is bigger than the 4, this is the a squared, this is the b squared, so that gets us going. And we also can tell now, just by looking at this, that we have a center at 3 comma negative 4. Okay, so let's see, if a is a, what do we got here? We got a is a 3, we got b is a 2, right? And therefore, in an ellipse, we're supposed to know, whoops, we're supposed to know, that's the key idea. There we go. A squared is the greatest of those 3 quantities. Not going to be true in hyperbola, by the way. So equals b squared plus c squared. So a squared is a 9. B squared is a 4. Whoops. So c squared is a 5. So c would be radical 5. Okay? So these are the important pieces of information so far. And I guess the next question is, how can you tell it's a type 2? You know, it's more vertical than horizontal. And that would be because the number here is greater than the number here, and it's associated with the y squared term. So for that reason, we know it's going to be vertical, okay, or type 2. So I'm going to get the coordinates to the center. 3 comma negative 4 would put that about right there. Okay, so let me see if I can 3 comma negative 4. And therefore, since the orientation is vertical, I count up a units and down a units to get the vertice, the coordinates of my vertices. So a is how much? A is a 3. So I'm going to count up 3. Okay, and I'm going to count 1, 2, 3 down 3. So this vertex here is 3 comma negative 7. I'm counting down 3 from negative 4. If I go up 3, I get this is vertex 2. vertex 1. I could call this 1, this 2. It doesn't matter. This would be 3, -1. Okay. Next thing are the foci. Well, again, you know, we've learned that radical 5 is approximately 2.232. So if I'm going to start here, I'm going to count up 2.23, about up 2.23, and that's going to put me about, well, let's see, this is up 1 unit, this is up 2, so maybe about there. So that will be a focus, and down, radical 5, 2.2 would change, so put the other one about there. Okay, so let's get the foci then. The coordinates of the foci, the x values are 3, okay, and the y values are up and down radical 5 units from the y value of the center. So it would be -4 plus or minus square root of 5. So those are the foci. Okay, so what do we got? We got A, we got B, we got C, we got according to the foci, we got the center, we got the standard form. What are we missing? Latus rectum. Okay, so let's do latus rectum. It's ugly. Is 2b squared over a. You put the numbers in. So what is b? b is 2, squared is 4, 2 times 4 is 8, a is a 3. So again, you know, we got the idea that the latus rectum is 2 2/3 units long. And where's my green? I guess I'll use orange. Hope this works. All right, so that means I'm going to go half of this, or 4/3, 1 1/3 unit in either direction to get the endpoints. And when I do this, and when I set this up for you on the problem set take home, I gave you a very nice grid. Okay, really, I did this in mathematics. I gave you a nice grid, so it's going to be easier for you than it is for me. Okay. Okay, so the other focus, 1 1/3 this way, 1 1/3 this way, approximately. Okay, so what's happening is you got this 2 2/3, which is going to help you draw your curve. Okay, now the other things which we didn't do is we didn't plot the endpoints of the minor axis. In fact, let's write that down. So the major axis has length, well, 2a. So a is 3, so 2a is a 6. We've already got those. Those are called the vertices. And the minor axis, okay, we use the b. So b is 2. We're going 2 either way. So 2b is 4. So the length of the minor axis is 4. We're going 2 units this way, which takes us to 1 -4. You're not asked, I'm going to write it down anyway. And 2 units this way, which takes us to 5 -4. And they would be the endpoints of the minor axis. And that's going to help us with our sketch, which for me is the toughest part because I'm off balance. All right, so that's not so bad. And the only thing I left out, I'm not even sure if it's mentioned on the sheets, is the eccentricity. So it's C over A, C is radical 5, A is what, 3. So this is less than 1, okay? Because this is 2.236 divided by 3. It's a little more than 2/3. We'll learn a little later on, eccentricity of an ellipse is always between 0 and 1. Eccentricity of a parabola is always 1. Eccentricity of a circle is 0. And we'll learn the eccentricity of a parabola is greater than 1. I'll make a nice chart for you. We'll go over that in a separate video. Okay, so this ends our second ellipse numerical video. You should be all set now to do the problem set. In fact, I think you'll find it kind of easy. So here we go. See you at the ranch.